sir.
Okay. The first announcement is we have to fast track everything. So we will have to skip a lot because we already have recorded videos of some of the lectures which I have to teach. Since I sent those links, people have not got back to me whether they've got questions or not. So my guess is I think people have understood. So there is topics on logic, conditional decision making. There is topics on looping. There is topics on file handling. There is topics on exception handling. There is topics on numerical computation with NumPy. There is stuff recently on how to make plots with Matplotlib with data visualization. So all those things, so far people haven't got back to me. So I'm going to guess that since people have got access to the videos and people committed themselves to watching these videos at the most convenient time, my guess is people are watching. And at some point, because we have spent so much of the year learning this bit here, I'll have to give out quizzes. And those quizzes will have to account for your CA. So all the links, I will take it I have taught. Because
Yes,
I have given videos to people, for people to watch while they're at home at their own time. And I think what I'm explaining, what my explanations in the videos have been very clear. Okay. Now this week, I want to introduce a module which is very important. A module which is called Symbolic Python. Now, Symbolic Python allows you to do mathematics the same way you do mathematics naturally, whether you're doing factorization or whether you're doing expansion or whether you're doing differentiation or you're trying to do the way you do integration with pen and paper or the way you do differentiation with pen and paper. That is what it allows you to do. Are we clear? The whole point of this course is that we need to move away from doing mathematics with pen and paper like we have already done. Computers have become available, so we need to find a way of doing this mathematics using computers because computers are faster. Are we clear? And you guys are doing physics.
yes, sir.
Since you're doing physics, you will not be able to run away from doing mathematics. In this time and age where we are in, just being good at mathematics and physics is not enough. You also have to be good at programming a computer so that it can do the mathematics for you. Are we clear?
Yes, sir.
Yes. Now, this is where we start. So the first way we're going to do is we're going to show you how to do your mathematics using something similar to what you have always been doing. When you're doing your expansions, when you're doing your factorizations and stuff like that, using variables X, Y, and Z, stuff like that. Okay? Now, the mathematics which a computer does, which looks like the kind of mathematics which you do with pen and paper when you go into an exam, whether it's classical mechanics or whatever stuff, that is what is called symbolic mathematics. It is a type of computer algebra. Okay? The computer is doing something behind, but that's not the point. The point is we want to give you a tool for you to use to confirm your mathematics. If you already know what you're trying to do, that's fine. But it's going to be faster if your computer does the mathematics for you, as you're going to see very soon. So we'll learn how to do certain things. How to create mathematical expressions. Later on, how to do differentiation. That's what we need to do. We will also learn how to do factorization, differentiation, integration, how to work out limits, how to do matrices. All those are things we are hoping we will do so that you will be able to start using your computers fully. Okay. Now, this symbolic Python which you're using, which is written as SymPy, this is a purely Python module. And it's one of those modules which has got applications in mathematics, in physics. We can use it for working out polynomials, as you are going to see in this course later on. We are going to be using another method to work out polynomials, how to do calculus, how to do matrices with linear algebra, how to plot graphs, how to do statistics, how quantum mechanics, and all these other things which involve probability. So this is basically where now, after learning Python for all these months, slowly, surely, now we start using this Python for our physics and mathematics. I believe up to this point, you guys now have the tools. If you have been watching the videos, I deliberately made sure that we took a longer time, but taking a longer time means that we run a bit behind. But at the same time, I wanted to make sure that you were not rushed. You did not feel like you're being rushed to learn something. You learned slowly, and that would help your understanding. Are we clear? So now we'll start using all this Python which we have learned. Is that clear? And if there is a part where you don't understand, please let me know where you don't understand. So the first thing we're going to do, of course, is something which is familiar to you. For us to use this Symbolic Python, we need to import this module. So we need to carry out an import of this module. Okay, and that's what we're going to do. So the name of the module is SymPy, here, SymPy, and I think I'm just going to import it as SymPy. Let me just try to, yes. The video is cut? Oh, okay.
The screen is not showing again.
Yes, I've noticed. Okay. I'll need to check whether my data is up to scratch or it's finished. Let me know if you're seeing stuff. Are you seeing?
Yes, I'm seeing.
Okay, so we need to import this module. We know how to do this. For us to import the module, we use the import keyword, which is here, the import.
Yes, sir.
Then followed by the name of the module you want to import. So when you do that, that's fine. So it imports, as you can see there. Next, we want to see what kind of things we are going to have access to when we use this module Symbolic Python. So we print the contents as a list, all the functions, all the values, all the variables which this module contains. So we know how to do that. We do that using that print. Now, as you're going to see, this is a list. This is a list, as you can see. It starts from like that. So you get the results of all this thing as a list, and you can see it is a lot. So this is not a small thing. Symbolic Python is not something which is small. It contains a lot of things. And some of these things which it contains are what we are going to use. We will need to learn how to use some of these things. For example, we can start identifying some certain things. For example, there is this one here. This is PDE. This PDE stands for partial differential equations. This is mathematics. You can see something here, ODE. ODE is ordinary differential equation. So Symbolic Python has the ability to help you. It has got the power to work out partial differential equations. It has got the power to work out ordinary differential equations. Down here, there's something which says poly. This is for polynomials, in my opinion. There are other things, for example, what else can you identify here? There's a lot of this stuff which is there. There's rad here. I think that's for radian. This part here, this is for the real parts, for complex numbers, so it can handle complex numbers. This is for the root. I think this is for finding the root. Then there are some solvers also. which can help you solve certain equations. If you want a solution, you've got an equation, you want a solution to that particular equation, you can do that. There is something which we have here, I think, let me see. There's a series, there's a sequence here, something which we can easily identify. Here, this one, I think we're going to look at, we're going to use this thing, simplifying. If you have an algebraic expression which looks very complicated, then you want to simplify this equation, you can use that function simplify. There's another thing which should be familiar to you here, as you can see, that is sine there. That is a trigonometric function, sine, so it's there. And the thing has cut. Okay, just a minute. So just a minute. Okay, I'm coming back. Okay, so there is that. You can see there's sine, then something, there's next to sine, there's something called sinc, then there's sine transform, singleton, singular, then there's some solving thing, solve linear system, UL. We're going to see how all these functions can be used with some of it now, but later on, even as we are doing the course. So we'll have two ways of solving our problems. There is this thing here, we're going to use this. I am sure you are familiar with this. That's a square root function. There's basically a lot of things. There's basically a lot of mathematics which symbolic Python can do. Here you can see there's pi. This is for plotting. Then you can have a point. Here, then there's this, there is parabola, there is a lot of mathematics really. And if there's a lot of mathematics, you know mathematics is needed in physics. So as a physics student, this should be music to you. So this is one of those things which you are supposed to learn how to use. Here you can see there's log, then this one, I think this is natural log. So there's a lot. This one here, something called a Jacobi polynomial. I think in the second part of your mathematics, as you do your third year mathematics, you'll be introduced to Jacobis and Jacobi matrices and transforms, Laplace transforms, Laplace inverse transforms, and all those things. There's a Kronecker, there's something to do with Legendre here. Laplace transforms. So you're going to do Laplace transforms in your mathematics. So then here there's inverse cosine transform. There's what else? So what I'm trying to say here is, as you are doing your mathematics courses and you are doing your physics courses, you will be required to do your mathematics with a pen and a paper. But the same mathematics you're doing with a pen and a paper can also, exactly the same way you're doing it, until you find the answer. That same mathematics you're doing with a pen and paper can also be done by a computer. Especially, it can also be done in Python. So your Python basically has a lot of uses all over the place. Are we clear? Just a minute. Okay, can you see my screen?
Yes, sir.
Yes. So basically, this is what I'm saying. What I'm saying is, the same way you do mathematics with pen and paper, that mathematics can be done with the computer. Even more importantly, since you have spent the first 6 months of this year trying to learn Python, it can be done with Python. And today, and I think today and for the next 2 weeks, I will show you how to use this module. The reason is, in computational physics, there are two approaches to doing things. Either you can do things using symbolic mathematics in a symbolic way, or there's another method which you're going to see how to use, which is what is referred to as numerically. So traditionally, this computational physics has always been done numerically, but we are going to empower you with another way of doing things so that you can be checking whether your answers are correct or not. Okay, so the first thing to do, of course, is we need to learn how to create variables. We need to learn how to create variables. And there is a function in Symbolic Python which you can use for creating what are called symbolic variables. Symbolic variables are your x, your y, your z, which you use in these expressions, in mathematical expressions. So we are going to import from the modules SymPy, we're going to import a function called symbols. This symbols function is used for converting strings. So we're going to have a string x or a string y, then we convert this string x, y into a symbolic variable. So we're going to run this. So from SymPy, import symbols. We do that. Okay, so the import has been done. Now, once symbols has been imported, we can use this symbols function to create symbolic variables. And how do you create a symbolic variable? Well, you just give, this is a string x. So using this string x, I'll create a variable, symbolic variable x, like this. So you give it a string. You can give it a string, one, like this, or you can give it more than one string, but those strings can be separated by commas or by spaces. So in this case, I want to create a symbolic variable x. So when I do that, I've created x, then I find out what kind of x, what is x, which I've created. Python tells me that x is a symbol. Are we clear? Hello? So I am told that
Yes,
Python is x is a symbol here. This is symbol x or y. It's a variable. Okay. You can also create more than one symbol at a time. And how do you do that? By this. So this symbols function, you can give it a string, but now we want to create a symbolic variable y. We also want to create a symbolic variable z. So when I create y, using this x, y, I'll create a symbolic variable y here. Using this z, I'll create a symbolic variable z like that. Usually they don't have to be the same. They always don't have to be the same. They don't have to be the same. What can I say? Sometimes it can be anything, words, but you want to change them into something else. Like I might show. Okay, that. Then here you type y. Y is now a symbol. Then z. Z is now a symbol. You can also, another way of creating symbols, like this. You can do this. Now these characters B, A, B, and C. You can create symbols A, B, and C. But here now they're separated by spaces. Like that. There's a space which is separating them. The space which is separating them here is doing the job of the comma which you have here. It's the same thing as having a comma here. A comma is a separator. Are we clear? The comma is separating y and z, and that's exactly what the space there is doing here. The space here is doing here. A, B, C, like that. Then type A, like that. So we have got A as a symbol, then you've got B as a symbol. Now once we create these symbols, then SymPy or Python will start accepting these symbols as things which you can use. Now, how can we use these symbols? Well, once you have created enough symbols, then you can create yourselves expressions, you can create yourselves expressions called algebraic expressions. These, for example, this expression, x plus y. Now it becomes possible for me to do this, x plus y. I can type x plus y. When I type x plus y, this is what I get. I get this. Is it clear?
Yes, sir.
It's like I'm just writing. Now I can write x plus y, or I can write x minus y here, like this. I can write x minus y. When I write x minus y like this, the computer now understands what I'm doing. Or I can say, look at this, x plus y plus x minus y. So in this case, x plus y plus x minus y, you've got 2x plus x, that is 2x, plus y minus y, that's going to give you 0. So you should end up with 2x. So if I do the same thing here, x plus y plus x minus y, when I run this, that's what I get. I get 2x. Can you see what's happening?
Yes, sir.
What we are now able to do, we have created variables x and y and z. We can now add them like the way we do algebra in normal mathematics. I can multiply xy. I can, oh, just a minute. Yeah, there's a bit of something here. It's left here. Let me create. So this, we are beginning to have the same kind of power which we have with our pens and papers, except now we are going to be faster. This one, x multiplied by y. If I'm going to do x multiplied by y, then I just multiply the variables x times y. We know how to do multiplication in Python. You use the plus, the star sign. If you do that, this is what you get, xy. If you want to create this expression, x squared, if you want to get x squared, then you have to multiply the variable x to the power 2. Right? If you do that, x to the power 2, you get x squared. The output is x squared. So you are now having the ability to create small expressions, but you're not limited to creating small expressions. You can do more than create small expressions. For example, here we have got this one, 2 multiplied by x to the power, let's say to the power 2 or to the power 3, like that. So this is 2x y3. So that bit, if I'm going to do that, then I'm going to have that 2x multiplied by y to the power 3, and that's what I get. This is exactly how you write your mathematics. Whether some expressions are going to factorize, or whether it's a quadratic, it's a cubic, or it's some formula, this is exactly how you do it. Is it clear what you're trying to accomplish here? Or what we're trying to get to? Here, I have an expression, x minus y, the whole thing in brackets, then squared. I do the same thing here. Open bracket, x minus y, the whole expression squared. When I do that, this is what I end up with. X minus y, the whole thing squared. I can create something which is, I've been creating smaller things. I can create an expression which is much more, bigger. For example, this quadratic thing here. X squared plus 2xy plus y squared. And how will that come out? I will be able to do this because remember I created a symbolic variable x. I also created at some point a symbolic variable y. So it's going to be x to the power 2 plus 2 multiplied by xy plus y squared. When I do that, that's what I end up with. I end up with x squared plus 2y plus y squared. Now, the good part is these expressions we are creating can actually be stored in a variable. We can store this so that instead of typing all the time, like we have learned in programming, with the Python we have learned, we can actually just be calling the variable which contains this expression. So what we're going to do is we're going to rewrite this expression, then we're going to store this expression in a variable called expression. This variable called expression. So we're going to do this. So this whole expression we have here, this side, we are going to store it. Admit. So this whole expression which we have created there, we are going to store the expression in a variable called. Can you see the screen?
Yes, sir. Able to see.
Okay. So here we have our expression x squared plus 2xy plus y squared. This expression, we will store it in a variable called expression, which is this one here. We run this. Okay. Now, instead of typing the whole expression, we are just going to type expression and run it. When you type expression and run it, that's what we get. So now we no longer have to retype the whole thing over and over and over again. We can just type out what the expression is. Do you see the advantage now of the Python,
Yes,
you have learned, of the idea of a variable which you have learned from Python? This idea of a variable now allows you to store this whole complicated expression. This might be simple, it's quadratic in nature, but you might have something which is some formula which is more complicated. You want to find a way of putting it somewhere. Okay? So you could do that. If you print expression, so if you just you type expression, that's what you get. You get something which looks nicer like that. If you print expression, if you try to print expression, things don't look so nice, but it's still the same thing anyway. So you get this. You get x to the power 2 plus 2xy plus y squared. Clearly, this is not as neat as this. So, going forward, we are just going to stick to typing expression and stuff like that. We will not be doing a lot of printing of these expressions, because if you print, it doesn't look so nice. Are we clear?
Yes, sir.
Okay. Yes, sir. Next, now that you have got your expression in this variable x, you can do all the other things you can do with variables. You can add another term, another variable, for example, to expression. We can say expression plus x. So that's going to be, you're going to add another x term to this thing. If you do that, expression plus x, then this is what you get. You get x squared plus 2xy plus x plus y squared. So it rearranges itself properly. It understands that this first bit like this, you've seen, it rearranges itself properly as your output. So you can have more than one expression, then you can add these expressions, you can multiply these expressions, you can do all sorts of things with these expressions. It's up to you. We do a bit more, but almost the same thing. For example, expression plus x plus y. So now we introduce this other symbolic variable which we created, y. When you do that, you end up with this. You end up with x squared plus 2xy plus x plus y squared plus y. Are we clear?
Yes, sir.
Okay. So that's how you create an expression. Now the next thing we're going to do, now once you have created an expression, sometimes you want to substitute a value for a particular variable. Okay, you can do substitutions with these expressions I've created. So once you create an expression, you can do substitutions. Okay, for example, let's look at our expression using what's known as a symbolic method subs. You can use the symbolic method. Remember what we know about functions and methods, a bit different. So you can use the symbolic method sub. So let's look at the expression which we have. So this is our expression, x squared plus 2xy plus y squared. Now what I want to do here is I want to make a substitution. Remember there are other symbolic variables you have created. You have created a, b, and c. Now I want to substitute for x. I want to substitute x with a. Here where there's x here, I want to put a there. Here where there's x here, I want to put a. So I'll end up with a squared plus 2ay plus y squared. Now how do you do that? You start with expression. This expression contains the expression which is above. Then you put a dot. Now after the dot, then you call this method subs. Then inside subs, you specify which variable you want to substitute for. So I want to substitute for x, and what do I want to substitute x with? I want to substitute x with a. Is that clear? You start with expression, then you put a dot after expression, then subs for substitution. Then you state which variable you want to substitute and what you want to substitute it with. So in this case, I want to substitute x, and I want to replace x with a. When I do that in expression, when I run it, this is what I get. I get a squared plus 2ay plus y squared. Is that clear? Oh, network. Just a minute. Network appears to be unstable. I'll go back again. So here, we want, can you see the presentation?
Yes, sir.
Yes, so what I was saying is we want to make a substitution of, we want to substitute x with a. So here where there's x, I want to put a there. Here where there's x, I want to put a there. So I want to substitute x with a. Now the way you do this substitution is there's a method, because now what we have is you have created an expression. So using this expression, once you have an expression, then you also have got access to a method called subs. So I write out expression like this. Then after expression, I put a dot. We have seen how this thing works, how methods work with other things. Then the name of the method is subs. Then I state which variable I want to substitute for. Now in this case, the variable is x, and what I want to substitute it with. So I want to substitute x for a. So when I do this, when I run this, this is what I get. I get a squared plus 2ay plus y squared. So x has been replaced with a. Is that clear?
Yes, sir.
If I display expression remains unchanged. It's still the same thing. So expression doesn't change. It's just changed temporarily, but it doesn't change. If I want to replace y with b, so here where there's y here, I want to replace it with b, like that. So I will start out with expression, then dot, then subs, then I state which variable I want to replace with. which variable I want to replace, which substitute is y, then what I want to replace y with. I want to replace y with b. So when I do that, this is what I get. I get b squared plus 2bx plus x squared.
Sir,
Yes.
I have a question.
Yes.
There, I don't know, like the codes. Can you take it back, maybe somewhere, code number 26 or 23?
20. Which one? 26? That's 26?
Oh, again. Go up.
Again, up? Okay.
Yes, I want to see where you are doing put the expression plus the x plus y.
Oh, there it is. There.
There.
25.
Yes. Now, since we have substituted for x.
No, here we haven't substituted yet. This is not substitution here. This is not substitution. This is just addition.
We have replaced where there is supposed.
This is just us adding things. Expression remains unchanged. You're just adding something to expression. Are we clear?
Yes. Now my question is, since we have yes, we are clear. But my question is, since we are in the expression there, we've said x is just the same as a. Does it mean that everything there is going to change, including the x that we have used there?
No, it's just substitution. It's being substituted for something. No, the one up here doesn't happen. Doesn't change here. This one remains unchanged. This one in 25 just remains like that. What's being changed is what's in the expression. This is what the expression is: x squared plus 2xy plus y squared. The expression we have stored, we have stored in expression. Okay. Any other question?
No question. Thank you very much.
Okay, you're welcome. Now, you can also, Symbolic Python also understands numbers. Okay? You can also substitute a variable like x for a number. For example, instead of x, we want to substitute x with 2. So if I do that, I'm going to have expression.subs. Then what do I want to substitute? Which variable do I want to substitute? I want to substitute x. Then what value do I want to substitute x with? I want to substitute x with 2. Like that. So I can do that. I run that. When I do that, this is what I get. I get y squared plus 4y plus 4. Remember what the expression is. So here I'll say display expression, so that you can see exactly how the substitutions are being done. Display. Display expression. So this is our expression. So this is expression. So for x here, for this x, you substitute 2 there, so it's going to be 2 squared, that gives you the 4. Then here, you've got x here, that's 2. So 2 times 2, that gives you a 4. So if you carry out such a substitution, then you're going to end up with this quadratic y squared plus 4y plus 4. Are we clear?
Yes, sir.
So you can actually substitute for a particular variable. You can substitute for some with a number. Again, yeah. So this is us trying to get our feet with this business of symbolic variables. Here again, we display. the expression x squared plus 2y plus y squared. Now, what you're going to do next is we want to substitute for y. We want to substitute the number 3. So there's y here. So put 3 there. So it's going to be x squared plus 6x. Then there's y here. So 3 squared is going to give us 9. So we're going to end up with x squared plus 6x plus 9. So when you do the substitution, start with substitution here. Do sub expression dot subs. Then which variable you want to substitute for? Y. Then which value you want to substitute with? You want to substitute 3 for y. When you do that, you end up with this. You end up with x squared plus 6y plus 9. Are we clear? Is it clear to everyone?
Yes, sir.
Sometimes you want to substitute for more than one variable at the same time. For example, if you wanted to substitute x with 2 and replace y with 3 in expression, then what you're going to need is you would need to give this information as a list of lists. This is a list of lists. So expression.subs, then inside this expression.subs, you have got a list which contains 2 lists. Do you still remember the idea of a list of lists? A list which contains other lists? When you're talking about Python
Yes,
lists,
sir.
yes, that's what you're using here. So this is a list. So you have to give the information like this. This is a list. This list contains the first list inside this one. That first list inside is x, 2. It's basically saying for the variable x, I want to replace it with 2. Then the second list here is saying for the variable y, I want to replace y with 3. So that's how you give the information. Like that. When you do that, okay, let me do that first before we complete that. We should be able to kind of anticipate what the answer is supposed to be and confirm with what the computer is giving us. Okay, so that is our expression. So if we're going to substitute x, is going to substitute with 2 and y you're going to substitute with 3, then here, so this is going to be 2 squared, that's going to be 4, then plus 2 times 2 times 3. So that's going to be 2 times 2, that's going to be 4. 4 times 3, that's going to be 12. So this is going to be 4 plus 12, that's going to be 16, right? 16 plus 3 squared, that's 9. Then 16 plus 9 is going to give us 20 what? 25, right? So this whole thing, when you do,
Yes, sir.
yeah, we should get 25. So when we carry out this substitution, like this, when you carry out this substitution, you get your 25. So it's possible for you to substitute any number of variables in your expression like this. You have to give your information as a list of lists, okay? So each list inside this list of lists should have the name of the variable you want to substitute for and the value you want to substitute with, like in this case. The first list contains the variable x. I want to substitute for x, I want to substitute with 2. The second list contains the variable y. I want to substitute the variable y with the value 3. Is that clear?
Yes, sir.
So this is how you would carry out a substitution of more than one variable at the same time. You are not restricted to only substituting other variables or some values. It's also possible for you that you can actually substitute another expression inside another expression. For us to show that, we need to create an expression, this one, x squared plus y squared. So we're going to store this expression in the variable first expression. So we start out with first expression, then in this first expression, you're going to store x squared plus y squared, like that. So we run this. Then we display first expression. There. X squared plus y squared. As we have shown, if you want to substitute more than two values at the same time, for x you want to substitute 3, for y you want to substitute 4, you have to give these values as a list of lists. And each list inside this list of lists should contain the variable and the value you want to substitute for. So in this expression, first expression dot subs, I want to substitute for x, I want to put 3, for y, I want to put 4. So that's going to be, if this is 3, that's going to be 9, then plus this one, that's 4, that's going to be 16. 9 plus 4, this should give us 25 also. Is the idea of substitution clear? The order in which you give the list of lists inside your list of lists here, first we started with x, then y. You can also start with y, then x. You can say, I will start with first substituting y for y, I'll substitute 4. For x, I'll substitute 3. You can start like this. It doesn't matter, the answer is still the same. As you would expect the answer to be the same. So the order in which you are giving the list of lists inside this thing doesn't really matter. The substitution is still going to be carried out, so it doesn't matter whether you start substituting with x, like it doesn't matter in real life, you start substituting with x or you start substituting with y, it doesn't really matter, the thing still comes out. Okay. The other thing which we need for our expression is a function called square root. We need to import the square root. So from Symbolic Python, from SymPy, import square root. So there's a function called square root. So we import that square root. Now, the reason why we're importing this square root is because we want to create this expression. Square root, then inside square root, 1 minus a squared. Remember, we have a symbolic variable a. So we want to create this, 1 minus x squared. So we create, and we want to store this in second expression. So second expression, this is second expression. Then we say square root, then inside this square root, now this is a function we have imported. So it has to be given some information. We say 1 minus a squared. Once we do that, we run this, then we display second expression. That's what we get. We get square root 1 minus a squared. Yes. Is there a question?
No, sir.
Yeah, these are things which can be done. This is mathematics. And now we're bringing that mathematics to your computer so that you can do things faster. Now, here's where things become more interesting. You can substitute your second expression in your first expression. Remember what first expression is? First expression is x squared plus y squared. First expression, this one, x squared plus y squared. So inside first expression, we can substitute second expression, but we have to state where we want to substitute the second expression. So we start with first expression dot subs, then we want to say where there is y, we want to put the second expression there. So when you do that, you're going to end up with x squared plus open bracket the square root of 1 minus a squared close bracket squared, and that's going to end up with x squared plus 1 minus a squared, like that. So if you do that substitution, this is what you're going to end up with. Minus a squared plus x squared plus 1. Are we clear? So you can substitute an expression inside another expression. It's possible for you to do that. So that's how you do substitutions. You can substitute other symbolic variables, you can substitute values, you can also substitute expressions. Are we clear?
Yes, sir.
The other thing we want to do is what's called evaluating an expression. Finding out what the value is as a number. We are going to create an expression, this one here. Remember we've imported square root. There's a reason why we did that. The square root of 2. This is a surd. If you still remember your SADs in first year mathematics, do you still remember your SADs? This is a SAD. So this expression, square root of 2, I can store it in expression like that. Once I store it in expression, I can display it. So this is what I get. I don't get what the actual value is. I get expression as a SAD. But if I really want to know what the value of, what is the square root of 2 as a number, then I have to use a method called evaluate function. I have to use a method called evaluate function. So I start out by writing the expression, then I put a dot, then evaluate function. So this function evaluate is going to work out what the number which corresponds to the square root of 2. So it's going to evaluate the square root of 2. And I get 1.414 like that. You can check out with your calculator if that's the same thing, so that you can develop faith in what these things are. I have a calculator here also. I'll check with mine. So I'll say 2 square root, 2, then square root. Yeah, it's the same. If you have confirmed that side, so you need to have a calculator nearby. Yeah, so that you can confirm that these things are actually what they are. Okay, so this is how you would carry out an evaluation. The other thing which is contained in Symbolic Python, which is important in our physics course, is the value for pi. So you can import pi from Symbolic Python. From Symbolic Python, import pi. Now, when you import pi like that, then you display pi. This is how it's displayed. There. Now, if you want the value for pi, you have to type the expression for pi, pi, then you put a dot, then evaluate function like this. When you do that, that's what you get. You get your 3.14159265358979. Are we clear?
Yes, sir.
So this is how you're going to be evaluating your function symbolically. There's another way. Another thing that you can do is an expansion. You can have an expression, then you want to expand it. Now, if you want to expand an expression, there is a method for that also, which is called expand. So here we create an expression, x plus y to the power 6. So this is the expression we've created here, x plus y to the power 6, this. Then we store it in expression, like that. Next, we can check what type it is. What is it we've created? We are told something. Or you can display it. Not even check. I think let me not check. Let me do display. I think checking is just a waste of time. You can do a display of expression. That's what we have. So you can actually create something which looks like that. Now, what you want to do is you want to expand this. If you want it in an expanded form, then you have to use the method called expand. So expression.expand, when you do this expression.expand, this is what you get. So you get the whole thing expanded for you. So you end up with x to the power 6 plus the whole thing like that. You can confirm if you with a rough piece of paper and you're very fast, but I can assure you the computer is going to be faster. Are we clear how we do an expansion? With expand?
Yes, sir.
Yes. You can even have an expression which is as complicated as this one, which is here. 2x open bracket inside open x squared plus 3 x squared plus 3 close bracket squared plus 3y plus 5 close bracket divided by x squared plus 3. You have seen this x squared plus 3 here. This x squared plus 3 there, x squared plus 3 there. You can create an expression like that, which is what I've done here. Then you can display the expression like that. Then after displaying the expression, I don't want to do this. It's just a waste of my time. which time, because we're already over time, then you can expand this whole thing. If you expand it, this is what you get. Are we clear? Now we'll go to an expression which is more useful, I think, in physics. Okay, with cosines and sines. So remember, I told you there's cosine and sine in SymPy, so we're going to import this from SymPy. Import sine and cosine. This is us importing two functions from a module at the same time. So we know how to do this. We have done this when you're doing imports. So here, the expression we want to create is this one: x cos, then open bracket, x plus y, close bracket, plus cos, open brackets, x minus y, like this. So we create this expression here, like that. Then we run it. Then we display the expression. Okay, now when we expand this thing, expression.expand, when we do expression.expand, nothing quite happens. The reason is because there's something which is missing. There's an argument which is missing. We need to tell Symbolic Python to say, look, we are trying to do a trigonometric expansion, not just a simple normal expansion. Are we clear? You need to tell Symbolic Python to say, you are trying to do a trigonometric expansion. So how do you tell that? You say trig equals to true. So when you say trig equals to true inside there, and inside the expand, now Symbolic Python knows that you're trying to expand some trigonometric identities. So now it's going to carry out that particular expansion for you the way you expect it. When you do that, this is what you get. So cos x minus y plus cos x plus y gives you 2 cos x cos y. The sine part has been removed. Remember, cos x plus y is cos x cos y, I think, plus sine x sine y, like that. So if you're going to do that, then you end up with only these. If you carry out this identity, if you check with pen and paper, you're going to find that that's what it is. Is that clear on how we expand trigonometric identities? You need to set your trig to true. This parameter, trig to true, has to be set like that for this to carry out a proper expansion. Are we clear?
Yes, sir.
There is also another trigonometric identity, for example, this one, sine x plus x, or basically sine 2x. Let me do this. Sine 2x. Sine 2x, which is x, which is 2 times x. This expression, 2 times x. If you want to expand, then you display these. Before we do expand, we're going to display it. Display expression. Expression. That's what you get. Now, again, as we have seen, this is a trigonometric identity. If you want to expand these, sine 2x, you say expression.expand. If you just do it like that, nothing really happens. But you need to specifically tell expand to say, I'm working with a trigonometric identity. If you do that, so you set trig to true, then you run it now, this is what you get. You get 2 sine x cos x as the expansion of sine 2x. Are we clear?
Yes, sir.
There is another thing you can do. We're almost reaching at the end. So we have looked at substitution. We have looked at how you can do an evaluation. We have looked at how you can do an expansion. The another process you can do with algebraic expressions is factorization. Now we are going to create an expression here, x squared minus y. Now x squared minus y is just basically, as you can Notice it's a difference of two squares. X squared minus y. That's a difference of two squares. So we create this expression x squared minus y, x squared minus y, that expression. Then we display that expression. That's what it is. We can factorize this thing. And how do we do the factorization? By using the method factor. We can say expression dot factor. Expression, then that, and after that factor. When you do that, this is what you get. You get x minus y in brackets multiplied by x plus y. That's a difference of two factors, the difference of two squares. Do we agree? That is the correct factorization?
Yes, sir.
Yes. You can also go as far as factorizing a difference of cubes. Whether this one is a bit challenging, I don't think I can do it myself personally also by hand. But if we trust what we have there, then we can also do this. So create another expression x to the power 3 minus y squared minus y cubic, like that. Then just display, I think here, display expression. Display expression. So it should slowly start dawning on you that what we have here is a very, very powerful mathematical tool. Very, very powerful. You can factorize this expression dot factor. Then this is what you get, x minus y, then inside you get this. Are we clear?
Yes, sir.
Yeah, so that's how you do the factorization. Last for the day is simplification. How do you simplify a complex algebraic expression? How do you simplify a complex algebraic expression? For you to do that, you have to use a method called simplifying. Or a function called simplifying. Method or function called simplifying. I think function. Simplifying. Symbolic simplifying, function called simplifying. Method, I think. Symbolic simplifying method. So we are going to create some complex expression. This one, x minus 1 squared plus sine x squared plus cos x squared. Now, if you know your trigonometric identities, you quickly realize that this bit here, x squared sine x squared plus cos x, this is just 1. Do you agree?
Yes, sir.
That's just the identity sine x sine theta squared plus sine x squared plus cos x squared. That's just 1. So this last bit, this side is 1. So that thing should disappear if you're going to do things correctly. Then this side here, of course, this is going to be expanded in one way or another, then eventually you get something. So we create an expression like this, x minus 1 squared plus sine x squared plus cos x squared, like that. Then you display the expression I've created. That's what we have. Now, if you are going to simplify, then you simply say expression dot simplify. When you do that, that's what you end up with. One of the ones here is coming from that thing. So you end up with x squared minus 2x plus 2. Are we clear?
Yes, sir.
Any questions?
For me, no.
The other people? So if there are no questions, next time we meet on Thursday, we're going to look at how to do differentiation using Symbolic Python, how to do integration, and how to work out limits. So basically we'll move to calculus for the Thursday class. Then I think the Friday class, we're going to look at the algebra, matrices, and stuff like that. How to do that stuff using Symbolic Python. It's going to be very handy for you so that you can have a way of comparing your solution. Even if, when you don't want to work out things by paper, if you know what you're looking for, You can work it out using Python. Like in this case, you get your answers, then you move on. Are we clear?
Yes, sir.
Yes. So this is symbolic Python is a very, very powerful way of doing mathematics. Right now, you'll be doing your mathematics, the third year mathematics. That third year mathematics, you'll be required to work out things. You need to know whether the answer you found is correct or not. So you can compare with something. How do you know whether this answer is correct? If you can do it symbolic Python, it's not going to show you the steps, but it will show you what the answer looks like. Are we clear?
Yes, sir.
Yeah. Okay, so we stop here. The video is going to be uploaded to YouTube for the benefit of those people who did not join our class. So we're going to meet on Thursday. We're going to look at Thursday, like I've said, we're going to be looking at calculus, limits, differentiation, and integration. Okay, so see you on Thursday, same time.
All right. Thank you, sir.
Cheers.